title, label, assignee, at me, project. Title, body, file, got it, label. All right, so yeah, back at it again, trying to work on the file system library. At some point, we just have to go full hog, as they say, as some would say, and finish it all, right? So the first task I decided to do today is generate a list of stuff to work on. All right. Wait, how do you... Hold on. What? How do I type emoji? I feel like I had this set up at some point, but I want to do emoji. Get emoji. I want to do the please. Red dot. Hello? Dot. This is so clunky. What? How do you Wait. Typing emoji Ubuntu. I'm not below using a non-cross-platform way. Blah 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 blah. Open GTK app. You can right click on text field and select insert emoji. Browse blah blah blah. Control plus dot. Is that a thing? No way. Oh, wait, no, that's comma. Okay, so what is a GTK app? GTK app. Do we have, is LibreOffice a GTK app? Ubuntu, to type emoji, just use OpenOffice, no problem. This is tricky, huh? Text edit? Yeah, okay. Let's see. Insert emoji. Dot. Red. This one. All right. Sorry. Just trying to update my stream information. Here we go. Did my copy not work, or did I use the Mac OS shortcut? Hello? Paste. All right. Wait. Swift, but OSS. Coping. All right. That's fun. I feel like at some point I had some sort of either Fish or Tmux plugin that allows me to insert emojis in terminals. Probably have to look that up at some point. But yeah, back to making the list of stuff to work on. Whoops. Let's see. If you're watching this, by the way, hello, good morning. All right. So I was looking at creating issues with command line, right? It seems pretty easy. Let's try it. Because func. Let's find a function that I'm sure that we don't have. How we're gonna read link, and let's create an issue for it. So the way you do it, right? You do gh issue and then create body. There's a title, I think. Title missing file path dot read link. It is interesting though. Why is this not a? Why does this take a path though? Oh, it's part of the real API. Huh. So maybe it's not read link. Let's just go for link in the sources directory. Read link. Maybe it's symlink. Oh, that's better. Read symlink. That's more like it, right? There we go. It's a public method. I mean, it's public, and I'm pretty sure it's a method, right? Yeah, it doesn't take a parameter, and it just like, you are a path. What if you're a link? Let's try to read your content. That's what this is, right? So, yeah, let's make this read symlink. And that's our title. That's the body is create method for on file path for reading the link, symbolic link, reading it. While reading, it's very strange because file path itself is not the same as like what resides at the path. So I always struggle slightly with like what do you call it, right? So it's like you're not reading it, you're reading the content pointed to by it, or it points to, right? Reading out. Just let's not get distracted too much. Query method, blah blah, and let's see what happens here. Okay, seems pretty straightforward and fast. What happened here? Great, we got it. That's it. So yeah, so sounds like all we need to do is I wish there's JQ for Tamil. Let me minimize this, because like I could write a JSON file with all the titles and bodies in there, but it's probably not terrible. Issues.json, right? And then we'll have a array, and then inside it we have a body and a title, and so there's read symlink, there's make symlink. All right, so make symlink. right? And then title, create path, file path dot make symlink. It is interesting though. Here why is it taking a path parameter? That doesn't make sense. Wait, is this just a straight up crazy error? Make symlink. Oh, no, of course. There's two inputs for making symlink, right? There's like, where do you want it to link to, and then the new path. That makes sense. So it's more like make symlink at, right? Create method for making symlinks, right? So we have one of these, and then we can just pipe it through JQ. Let's first do this, and then I think you can do something like this. No. What do we do? We need to. You know, it's just much easier if I do a similar, like I use Python for this. So let's move this to comma separated. Ray. What does V stand for? SV file volume or something. Values. Stop with this nonsense. Values. Sorry. All right. Let's just use a comma separate values. That's so much simpler. And all we need to do is to not write comma in our sentence. There we go. Join these. Delete all the leading. Okay. All right. So I can just like Python, blah, 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 blah. Yeah, easy. All right, let's get down to it. So we've identified make link. What else? Yeah, I don't know what's a good way to do this. Let's do maybe, like do space, right? A number of spaces plus, and then public. What happens here? All right, so there's 196 public stuff. In sources, still 196. So first of all, you know, this library is no joke, right? We have a whole bunch of good stuff here. So how can we extract useful information from this list, though? Maybe it's just a pretty manual process. All right, here's an idea. Follow symlink. Follow symlink, not symblink. Okay. Here's some ideas. You know, let's just use the documentation. I have the API references here. So follow symlink. There we go. Yeah, so another challenge is to remember what I named stuff. I think directory content is a collection, is a sequence. Okay. Right. So we need to support follow symlink in directory content. And then we'll just repeat this sentence. All right, that's another issue, right? Yeah, of course, when you read metadata, support basically the same thing, except directory content is now reading metadata. There we go. All right. Next. Exists, of course. To be honest, now I'm doing this. It felt like even CSV is a little excessive. Like I just want same title and body probably most of the time. What else? What is this? Copy. Yeah. I think I don't have copy yet. Copy. Nope. So the first thing is create file path.copy copy file. We want to copy file first. Let's do it separately. So we have this, and then we want this as well. All right. Okay, there's two separate tasks. All right. So that's all the symlink related stuff. It's going to be super hard and whatever. What's next? I kind of want to rename metadata to file metadata just to follow the, oh, it is file metadata. Perfect. Thank you, Past Daniel. Let's just rename this file right now. Well, actually, I'll do it later. I almost wish they used like the file as a namespace and then putting like path and blah 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 in there. But you know, I understand it's adding namespaces is tricky. But one of the things I want to do is to straighten out the differences between the file metadatas. I want to fall a line on my original idea here in this library. So let's see. We have the file access times, right? We can ignore this for now. The type is fine. Yeah, the permissions is the thing that's tricky because permission here is a boxed value. Yo, Glad. What is that emote? Yeah, so this protocol you're supposed to use it as an existential. It has only one value, and the way you're supposed to get more information out of it is that you cast it into the native format, and then you open up with more stuff. That's a old design. I don't know if it's really. good for this new library, but yeah, you can see there's a thing called Windows attributes, right? Windows attributes will have a whole bunch of other stuff that's pretty useful on Windows. I'm really tempted to just fuck it and copy this whole thing over. And that also means our permissions here will also change. But the tricky thing is, like, file permissions is a Swift system construct, right? Let's take a look at the other thing that conforms to attributes. It would be this one. I called it POSIX permissions, right? So what does POSIX permission has? It has all the it's really the file permissions. Yeah, maybe this can work. I'll just take the same approach. Yeah, let's do it. So before I do anything, I was collecting the list of stuff to do. So let me collect it. I'll make a GitHub issue for each one of these, right? So let's create cross-platform permission data structures. All right, here's the different body than the title. We'll have the permissions protocol plus what else? There's permissions protocol, Windows attributes. Yeah, that's good enough because we'll also make file permissions conform to permissions protocol. Yeah. Good. Okay. So that's another thing. And we can actually let's just do it. So let's fire up the Python. Oh, how do I do this? Let's just write a Python script. Make issues Python. What do? We read the file, right? Issue CSV. We read it. We split it by comma. Now we have. Well, we split it by. I guess we can read lines, but we'll just split it by the lines first. For line in, right? Wait, is this not how you do it? We open it with open issue CSV as CSV, and then we do CSV read, right? If you read it, you can split it. No? Oh yeah, I think we're good. And then we split the line. Okay. Issue is the line split by the comma, right? Now we have the title, whatever. Oh, let's just make it explicit for our best viewing experience. We have title and the body, and we'll import a subprocess here. Or rather, from subprocess import subprocess. No. Wait, is that not? I never, well, whatever. Okay. So now we have the title and body. We just call subprocess.check call, I guess. Not really. We just call. We'll call GH, right? And we'll give it issue create body title. I just prefer Python instead of a shell script. Obviously, I can do all of this in shell scripts, but I'm not good enough with shell scripts. Let's just say. So we open the file, we go over the lines, we split the line, we have a title body, and then we call GH with our command line arguments, right? Should be simple enough. Let's give this the shot. Python 3 make issue. Oh, there we go. Okay, we got it. Look at this. Boom. Okay. List out of range. I bet it's the last line. Oh, crap. There's a comma in here. All right, it's fine. We'll fix it manually. Create platform permission. Yeah. Yikes. Okay. Good enough. Okay. Let me just nuke all of this stuff. All right. Let's begin. So I want to do this first. So there's a thing called permissions, right? This is the protocol we want to copy over. Just literally copy it. Pathos sources permissions. Oh, no. Pathos permissions. Sources, metro permissions. Okay. So now I have this. Let's open it up. Permissions. And then we will import system extras. Well, actually, no. We want to import system package, right? And then we'll make extension file permissions. Yeah, I like the description as well. It says OS agnostic, right? That's totally what it is. And then we need to take a look at the POSIX permissions implementation here and copy this one. Is read only. Okay. Let's build this stuff real quick. Shouldn't make any problem. Okay. And then let's do the Windows one. Let me think. So, all right. So there's some downstream changes here. When I create, oh yeah, let's update the metadata thingy. I want to first move this file's name to align with the actual type in it, which is file metadata. And then I'll switch this from the hard-coded permissions to this. I can delete the to-do now here. Let's just use 4 spaces now. I'll fix it later. I think now I'll just let the compiler tell me what I need to update, right? Yeah, the tests. The tests is now a problem. Actually, this is good. Well, actually, yeah, this is perfect because temporary. We can just call meta permissions is read only. Is read only. I guess it's the opposite of that. So, right? You having the right permission is the same as not read only. Yeah, that's correct. Is read only. Let's keep going. Another one. That's 3 of those. Hello? There's more. Yeah, so yeah, we need to update the sample app now. The sample app, before you can run it and it'll give you like the permission bits like ls-l does, right? Like with this. But it turns out it's not super meaningful on Windows. You can see them like with the pretty bits and whatever. Like actually I can show you probably dot build debug ls.exe. You can see these bits, but they're fake. Like especially for groups and others. So so let's fix that. We don't want to be fake. We want to be real. All right. So for this permission string thingy, we just literally say let's just straight up say this. Meta is file type. What did I say? Is directory, right? I can just say this. Actually, the long-term plan should be having a type string. Type string. And then we can do... No, see, that's another interesting thing. On Windows, you can be a directory and a symlink. Both would be true. So what do we do here? So you see my dilemma here. I was gonna say true, false, or whatever, but what do you actually get in real life? You have a D, I guess it represents directory, and then you have a A, I'm guessing represents some sort of file, right? And then on Windows, it's super rare to have a link. Maybe let's just do that. Yeah. Let's start with an empty string, and then we'll do well, we have to mutate it now. So type string meta file type is directory. If it's directory, we'll do D. Otherwise, we'll do dash. I feel like I literally just deleted a line like this, but if it's file, we'll call it F. If it's a link, it's symlink, we'll call it an L. Easy. All right, so here we're just putting our type string. You know what? While we're here, we might as well add the last bit, which is read only or not, right? So if the meta is read only, we'll add nothing. Otherwise, we'll add a write bit. Yeah. If it's read only, I guess it's always there's always an R there. So we just need to 1 bit represent this value, which makes sense. It's a Boolean, right? So now we have a type string, a size string, and the actual path. Oh, right. We need to dive into the permissions thingy. Okay, let's give that a try. So this is what it looks like. We can see this is a file, and we have write permission, file write permission, directory write permission, blah, 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 blah. Okay, good. It looks kind of funky, but it's just a matter of getting used to it, right? Okay, so I think when it comes to metadata and when it comes to creating the value for permissions, right now it's the same logic across all platforms. But on Windows, we need to introduce the file attribute stuff to make it work differently, right? So Windows attributes. Oh, this is a big change. All right. So copy this to our thingy. Let's take a gander. I think it's pretty standard. You take a word, and then you just get your information from the bits in the word, right? Okay. What do I do now? I feel like I need to branch, so let's do that. New permissions. Let's just get all the stuff in there. push this up. This is tricky. I mean, it's fine. We'll just like fetch it, check it out. New permissions. Oh, there's some changes apparently. Ah, that's fine. I think I was contributing to the Swift system package and ransom tests. Okay. Okay, new permissions. All right, we'll just edit over here and test over there. So the first thing I can think of is sorry, I'm listening to this music. It's just bang, and I couldn't share. First thing we need to do is we need to bifurcate this implementation. So given the file path, how do we get its metadata, right? Before, you can just use this stat thingy. But no longer, right? Oh, actually, I regret closing my other tab. Yep. Metadata plus Windows. Here, apparently, we can do something like this. Should we just copy this? Why the heck not, I say. No. This is just an initializer. So on Windows, we can look here. How do we do it? Yeah, this is also the same link part. That's the hard part. Okay, we call this. We check a bunch of stuff. Yeah, we'll need the initializer anyways. And it makes sense, right? Okay. Okay, so I guess first let's refactor a little bit. Make a initializer if OS is Windows. Else and if I think you can do something like this. Let's even call it status. I think it's not really called status, but I like to think of it as status. It's like file status. Okay, so we got the mode. We got the permissions. And that's literally our permissions. So We got the type. And then we got the size, right? Okay, so that's what happens on non-Windows platform. And down here, we can simplify all of this by saying just feed it the status object. Okay, that's number one. And number two, we go back here, give it an easy copy and paste. We probably need to do the import here. Okay. So and then we also copy the implementation, right? Forget about follow link for now. There's no follow link. And then we need to do the Windows flag here. Else here. Copy here. Indent everything. Okay. So we need to do self.with platform string. And you get the C string. Now you get the C string. You can do this. You call first file handle W, right? What is data? Data? What's data, Daniel? Data? 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 Oh, data. Okay. Oh, we have data here. Okay, so this method gives you a handle and also updates the data. You check against this, and then you have to somehow throw the Windows error, right? What is that? We need to do Erno raw value -1, I believe, and then you say to do map Windows error to Erno. Okay. And then you close the handle. Wait, is this right? Oh, yeah. If it's invalid, you don't need to close it. Right. And then once you read the data out, you don't need you can close it. So this is fine. Like you don't need to do actually it's wrong to do defer and close. And then we have the file metadata and calling this initializer, right? Yeah, so here the permission would be a Windows attributes. We don't need all this time stuff for now, so we can get rid of that. We're getting the is dictionary, is symlink, is file, and then we get the file type. Oh, file type. Let's see, file type. Wait, what? What's going on here? Whose file type is this? Mine? Interesting. So this logic is already there. So we can do self.size, self.permissions, self.file type is literally a file type that takes the data, right? That's pretty neat. Let's do it in order. Also, I feel like this is wrong. Yeah, this is a bug. Whoops. Right? So this is 32-bit unsigned integer. We need to first convert it to a 64-bit and then shift its bits. Because if you shift its bits earlier as a 32-bit integer, you would just wipe out all the bits. Yeah, okay. Not sure why this is public. Let's not do that. I can see why. Yeah, actually, it makes a lot of sense to be public. Because this ultimately is a public type, right? Yeah, okay. So another thing I need to do is this system stat struct thing is kind of cringe. Internal, because it was supposed to be, yeah, using the wstat 64i32 on Windows, but it doesn't really make sense now because I totally bifurcated the implementation on different platforms. So we can just use a stat thingy, I think. But this now makes me have to actually. Let me think. Before we move too far away. Let's just get rid of this. And keep this, right? And then now I get to delete the stat, but keep the call. I'm so much regret. Okay. Yeah, I want to keep the... Yeah, I want to do this. But that means I need to import a bunch of stuff. Like this, all this stuff. What's the best way to do this? Because the whole point of having this file is so that I don't have to do this imports again and again and again. Maybe I keep the system stat alias here. Maybe I even do it this way.
Nope. You see, I kind of want to make that initializer public. That's where all this trouble came from. So I think the short-term solution is just to make it non-public, right? If it's non-public, then I get to use this alias. Yeah, system stat struct. Now everything is good. Wait, what's wrong with this? Value of this does not permit conform to, oh. All right. Let's see what Windows think about these changes. And the ultimate test is our sample app, right? Oh. Okay. File metadata. 35. This is trying. Anything else? Oh. So this, I guess we need to make it a 64-bit. Read write. Okay. We pull and we build. Now there's a bunch of renaming related stuff. Is that all the same error? Oh, data. Okay. Wait, what? Oh, file type. Doesn't matter. These types are self-documenting. So I'm assuming that means I need a little bit more changes over here. Actually, I should do this. EA run search Swift build. All right. Okay. Okay. Directory content data. $69. Nice. As soon as we get this to build, we can play with the sample app and see what happens. Okay, everything is built. Also, let's run tests. Oh. Permissions has no contains. There's more of these, huh? All right. Okay. So what's this? Setting file permissions. So it was not, and then we made it is read only, right? File path as no member set. That's interesting. Oh yeah, that's because permissions now needs to be cast. Yeah. So what do we do here? Actually, we probably can do it like this. As what did I call it? Oh, file permission, right? File permissions. Oh, right. We need to change the set permission stuff now. Let's see. Func set working directory, set permissions. Should we make this It's probably okay. I think we can take the existential or we can take the concrete type on different platforms, right? Wait, where's my set thingy? Did I just delete this? I just deleted it. Huh. Okay. So let's put it in here. The reason I want to put it in here is because we already have a bunch of compiler directives. So and if Windows. Okay, so let's call this the Windows attributes. And then we don't need to cast it anymore, right? And in here we can just say self dot with platform string. Let's put a try here this time. And then we just call this. Call our set Windows attributes W. And then we get our raw value here, and then we throw the error with the to do. Okay. And on the other hand, we'll also steal from here. Oh. No. This one. Ah, this is just a straight up change mode. Okay. So same interface. Well, should we do it? Yeah. Well, doesn't matter. So here is a file permission. We still do this. And then we do this. But we want to call, I believe, system change mode, right? And we no longer need this on Windows. value. System error, no. Okay. What else? What's permission? Permission should have raw value. Yeah, raw value is the mode, and then you can give the mode to system change mode, right? System change mode takes the raw value, takes the mode. Yeah, perfect. So this should compile, and then we need to go back to our tests. Let's just do it again. All right, here. All right. So what's this? Test permissions. Oh, this is just literally permissions is read only. Okay. Oh, okay. Oh. Okay. Cannot find type Windows attributes. Uh-oh. Did I not copy that over? Huh? Must be an import problem, right? Oh, wait, that's a variable. I'm confused. Well, isn't this... Huh? Windows attributes. What do you mean you can't find this? Window attributes. That's my bad. Oh, I can't edit over here. I need to edit over here. Sorry. Okay. Windows. Oh, this is just the inferior terminal. Let's just use this. Okay, Windows attributes. It's still complaining about this. Oh, that's because the variable name is wrong, right? the variable name is actually permissions. And then just to be sure, let's call Windows attributes permissions. It's a word. Okay. Very good. Very good. All right. Oh. All the tests, I think, built successfully, and all of them passed. The last thing to do here is run the sample thingy, OS. Okay, so we've got, this is a directory. They're all writable. This is all fairly good. Let me think. So this test right now is running only on Unix. Maybe I should try to run it on. Let's take a look. So I need to be able to flip the is read only thingy. So the file is read only. Application can read this file but cannot write it. Blah blah blah. You cannot view or change the read only file. Windows 7. Okay. Let me take a look at the specific value of this guy. It's just 1, right? So I assume if it's 0, oh, I see. Oh, it's static. Oh, this is a, oh, yes. Option set, perfect. Perfect. So this test can be real nice, actually. So we get our temporary directory, we make a file, we write to it, and then we get the old permission, but this time it's a Windows attributes. And then we can say, hey, assert false. The old permission is not read only, right? And then we get to set it by saying the old permission adding the read only bit. And then we get the new permission again as the Windows attributes. Oops. You know, now I'm starting to have hesitations, like the casting thing, I'm starting to feel a little uneasy. But this time we assert true that this guy has read only. Is it read only or read only? Like a bigger O or small O? Read only. Yeah, oh, it's a small O. Read only. Let's make it a big O. Okay. Yeah, now I start to have reservations about the type safe thingy because let's say if you're a user, you just want to copy some permissions around, you shouldn't be able to worry that. You shouldn't have to worry that these permissions are of a specific type. So yeah, I should just stop doubting the older Daniel here and just take the permissions. Guard let permissions is permissions as Windows attributes else fatal error passing attempting to set Unix file permission Unix on Windows. Okay, and then we'll do a very similar thing here. We need to make sure this is a file permission to set Windows attributes on Unix. I'll just get rid of the commas. All right. Okay. Is it finally done? We added a unit test too, so that's really cool. Windows attributes has no blah blah blah. Yeah. So what is what's the opposite of subtracting? Swift option set subtracting. Oh no. That's just part of set, right? Okay. Is it union? Yeah, it's union. Wait. Oh, yeah. It only happens on Windows, right? Okay. Oh, it failed. Permission denied. Do we know? Hmm. So I'm assuming this is where the permission denied came out. Huh. No. It's after. So we asserted it's not read-only. We change it to read-only, right? And it's all good up to the point. So the only time is this. The only possibility where this happens is when we access it again. So how do we access this thing, right? We call oh, I see. It's when we clean up. So when we clean up this temporary directory, we will try to delete the file because it's read-only, everything fails. That's what happened. Okay. So we need to set the old permissions again here before we restore the write permission so we can clean it up. All right, that's better. That's not too bad. All right, hopefully this time the test passes. Yes. Okay, that's not too bad. Took me less than an hour, right? Yeah. For this amount of change, yeah, it's not bad. Let's well, I guess just make a pull request. Implement more better file permission. Okay, and then we also have a matching issue to close. This is number 32. Closes number 32. Boom. We will auto merge. Okay, so what's next? Man, this is gonna be hard. This one. This is gonna be hard. Okay. Read. Wait. Metadata plus Windows, I think. Read meta. All right. I want to take a look at what it takes to read metadata following a symlink. So we need to have this thing called a final name. What is a final name? Okay, it's a private function, and it takes self and returns another instance of path. It calls get final path name by handle, which means you need to first open a handle. Okay. An opening handle calls for creating a file. Okay. So let me guess. Once you have final name, right, then you can implement things like, what's this? There's so much complexity. Get final path name. Oh my god. Oh yeah, once you do that, you have to, you can start going down the rabbit hole of like resolving nested symlinks. Okay. What about read symlink? On Windows, read symlink means, oh no, it's this crap. No, 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 no. Yeah, this symlink stuff always scares me, especially on Windows. On Linux, everything's so good. On Windows, everything falls apart. Yeah, so once you have metadata, you can implement exists. Yeah. So get final path name is not the same as getting the same link. I see. Okay. Let's make a file that's Windows only. And then let's throw in this final name thingy. It's not on the top of the whatever. Okay. Okay, so to make this work, we need to do the with handle. Okay. So with handle has this access thing, a disposition thing, attribute thing, and then it takes a closure. So we want self with platform string, C string, and okay. We take the C string, we take the access, blah, 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 blah. If we check this, if it's a problem, we'll do error no raw value -1. And then eventually we'll run the handle. Okay, so final name is, we call the handle itself, call with handle. Is this really necessary? Contiguous array, blah, blah, blah. Okay, fine. I think you do platform car. Is this public though? C interop. I think it's public. No way. Don't call it internal. Oh, it's public. Okay. cinterop.platform car. That's what I want. Cinterop platform car. Okay. Yeah, that's imported. Good. And here, finally, we will call the Windows API that gives us the actual goods, and we'll throw the errors. Error no raw value -1. We mess with the buffer a little bit. That's just not necessary, right? I feel like this is some old stuff that I need to fix. And let's see what file path has for us. Initializer system string. What's a system string? System string. No, finally, system string is internal. System string is internal. Oh, at least it takes a collection of cars. Where car is a system car. Oops. What's system car? System car again is an internal thing, but it's a wrapper on platform car, right? And yeah, it does the little check here. Okay. Then that just means system string, or the initializer is internal, right? So we cannot take a system string and create a file path out of it. That's most unfortunate. I mean, there's so much symbols in this library. It's very hard to navigate with just text search, I guess. Let's just browse around and see what we can find. File path string. Oh, it takes platform string. That's good. And I expect it to be a null terminated. No problem. Okay, this is what I need. This is what I need. Oh, this is even better. A null terminated platform string and takes an array, right? Okay. So we have a contiguous array and it is null terminated here. Is a contiguous array an array? Forgot. It's probably not. Yeah. I mean, I can just make an array here, right? Yeah, I can just make an array. And hopefully we can just do array, and then we can call this platform string. We'll return file path platform string. And it is this. I mean, this is really inefficient though. Like, you literally do a search, whatever. Let's call this guy platform string. Okay. So this is interesting. Let's make another branch. What's this? What are we working on? What is this? We got the file handles, we file name. Okay, let's do symlink. Add internal, well, add, what are we working on eventually? So we have the final name so that we can do, support follow symlink for metadata. So this is actually a ticket. This one closes 28. Of course, this is not complete in any sense, but we want to first check that it builds on Windows. Symlink. The chance that it builds is very thin, but if I feel like did I not import? I guess I didn't import Win SDK. That's a rookie mistake. And I misspelled something. No, it's no, not Aaron. Aaron is too pronounceable. Okay, looks good. All right, so that did absolutely nothing, right? It just added some internal utilities. Now we can use. Let's just make this even more explicit. Windows final name, okay? So we have with handle and Windows final name. Now we have this. We can go back to metadata. All right. And we can follow this now. So instead of doing self, we need to do a path. Path, and we'll do follow symlink bool false, and then if we follow symlink, we will first call Windows soft Windows final name. Otherwise, we'll do self, right? And instead of doing self here, we do path. Okay, and we have to update the Unix implementation as well, which I think is not easy neither, right? Yeah, because we have to bifurcate the stat thingy. All right, so now let's go to internals. Stat, where is it? Okay, so let's make another one. So we have stat, now we have lstat. Everything else should be the same. Okay. We have to decide which function to call. The real stat is, if we're following symlink, then we would have to call, is this right? Wait. Google it. Stat versus lstat. Okay. Lstat is identical to stat except for that if path is a symlink, then returns information about the link itself. Perfect. So I just want to make sure the order is correct. Yeah, but it looks like it is. So if it's this is not the best, but okay. Here we will use system stat. Otherwise, we'll use system lstat. And then instead of calling system stat, we'll call real stat. Well, let's call it any stat. How about that? I like that. Okay. Why am I here? Get me out of here. Okay. Let's pull it. Let's build it. At this time, we'll just have to assume it works. Because we can't create or read and write symlink yet, so which means we can't test it. Also, symlink on Windows is super weird. Like you can't really use it unless you're in a system like a administrator mode. Okay, so things built. Again, that just means we're good to go for now. What do we do here? We add support follow symlink following symlink in file metadata. Wait, file path.metadata. Okay. And we enable auto merge. Okay, so immediately after that, we will be able to update exists. Where is exists? Follow symlink. Right, and then we need to update the docstring. To include this. Something's weird here. Okay. I think I probably should update the docstring here as well. If there's any docstring, which appears that we don't have any, that's fine. Okay, so this just calls the thing we just implemented. So it should, well, the workedness should just inherit from this previous change. The workingness, the correctness. Okay. So that's probably another issue we can close, right? Unless, yeah, here. That's number 29. Support follow sim link. I just realized something. That's good. I'll explain real quick. But before that, let's write up this little pull request. It won't pass CI. CI will scream about this, but that's okay because we're just waiting on. Well, actually, no. CI will not scream on this. This will just sail through smoothly. That's good. Okay, so the revelation I had earlier is this. I want to see if read symlink is being used anywhere. Well, actually, is it that bad? I mean, it's being used somewhere, I guess. Let's see. What is this? We're reading the symlinks. Oh, yeah. As soon as you start visiting the content of the directory. Okay, then. Let's take a look at the read symlink. The beast. It's not here. It's here. No, that's the... Well, let's take a look at the Unix version. So here we need to make sure the file is a symlink. As soon as we realize that, we shall call read link. That's about it. And the Windows one is the beast, like the nastiest Swift code I've ever written in my life. But the good thing is the research is done, right? I know that it works. I know that it works. Yeah, it seems terrifying. Yeah, so it has a bunch of things like if you give it certain flags, it will give you an array, right? And then the array is a bunch of data, and you're responsible for casting it into different things. And then that's okay because you can cast things in, in Swift as well. And then there's enums inside this data. Sorry, not enum, unions. Unions is a feature that C-unions is a feature that Windows does not support. So you have to work around that. And then there's the thing called the flexible array member, which is a C feature where you can have variable size for a struct, and the last member of the struct is the variable part. That's another feature that Swift doesn't support. So you just like have these nested like C conventions that Swift doesn't support. So I have to manually do a lot of like pointer math. And then I have to cast things around like from bytes to 16-bit words, and then use the count, and then I have to cast it back. And anyways, it's a whole thing. But the good thing is like I don't need to relearn all this. I can just copy this and translate this code into Swift system. Oh yeah, no. That's not the end of it. Because I have to include a freaking C struct just so I can to help me parse the data. I think. Let me see. There's Windows helpers include reparse data. I have to include all this stuff to use it. So there's this thing called reparse data buffer, and then there's also this thing called reparse data buffer, mount point reparse data buffer, and I believe they are used here. Yeah, so I have to leverage their memory layout to read this data. Oh my god. Zero out of 10. Would not recommend. Flexible data, flexible struct sounds horrific. It's pretty nice if you're writing C code. It's like workaround for something, but oh yeah, if you mean in general, yes. Cause yeah, this thing device I/O control, it literally gives you just a buffer, a data buffer. Yeah, it gives you this thing. Wait, I want to make sure I understand how this works. Yeah. So I'm giving it the base address, but it gives me the size here, right? Yeah, it gives me the size, and then later I have to use the size somehow, right? Oh no, the size is the size is the word count. Yeah. You see, that's another thing. Like it gives you byte count, right? How many bytes of the buffer array. But then later, when you're trying to interpret it as, your end goal is to, like from this index to this index is a path, the path of the symlink that points to. But at that point, you're dealing with the Windows, like I guess in Swift System Parlor is Windows platform character, and that's 2 bytes wide. So this size you can't use it directly. You have to, do the divide by 2 thing. But the more I read about it, the less I'm scared of it. That's the good phenomenon that's happening here. What if we just copy this thing over? Let's see. Specific to my old library, there's throwing errors. Most of these things are okay. Most of these things are okay. And we just learned today that we can do this. If we have a null terminated array of characters, then we can create a Swift system path. So maybe we can do it. I am building up courage. Let's see. Okay, that merged. Do I have a read symlink? Yeah. Let's do this. Huh? Okay. Whatever. So to make it compile is not that terrible. we need to introduce a C module. What else? This have to be file path platform string, and then the array of something something. And then when we throw errors, we have to say error no raw value. Same thing here. Okay, so everything else doesn't seem too bad. The only thing that's left is to have to having to include that C struct. That means I have to change my my project structure a little bit. Like, for example, I have to do a new folder, system extras. And then we need to, the good thing is that we can steal, right? So I can just do, we need to add a new target, obviously. C system extras. Doesn't have any dependencies. Oh, I don't need this anymore, I think. But we'll see. I mean, it's a module. It's a C module, which doesn't change anything. We just need to make our original module. I mean, module. I'm used to saying the word module. It's a target. Depends on it, right? C system extras. And then we have to make the headers. Let's just copy. Oops. Yeah, you need to have an include folder. And then in there, you have your stuffs. What's in Windows helpers? Oh. Okay. Reparse data.h. Wait, what happened? Oh, nothing. Everything's right. Okay. Copy it over. Don't sweat about it. And then we make the module. Let's call this C system extras. We need to flag the thing so that it only includes on Windows. So, like, we can learn from here. I mean, I need to look it up somehow, right? So, yeah, this. Oh, I like this convention. You can just call it, instead of the specific thing, you can call it the generic thing. C system extras.h. And then here you can, oops, C system extras h. Okay. But almost forgot. We need to do this. Okay, so this should be pretty. Oh, C system extras. Okay, so this should work now, right? Do we need a dummy C? Yeah, we do. Interesting. Okay. What could go wrong? Everything seems fine here. Read symlink. Okay. So we have the branch. Let's go to Windows. And let's build this. It would be amazing if it just builds, but yes. Okay, that's not too bad. Oh yeah, I didn't push it. Whoops. Oh! Wait. Can't find his handle with handle. Just need to rebase. Hmm. What's happening? Isn't this with handle? If OS is Windows, do this, right? And then in symlink, we use this, no? Isn't this what I think it is? So it has with handle access disposition, deposition and attributes. Access deposition attributes. Access deposition attributes. What? It is interesting though. It compiled Windows.Swift later. And it complains about symlink. Let me see if I can fix this. This PC users me Swift system extras build delete. Okay. Sim error. What if I move this over to Windows.Swift? So yeah, what if I move this here? Wait, what? Hold on. Oh, I see. I didn't do this. What the? That's really dumb. I forgot to put it in the scope. All right. Now we're better. System error. Reparse data buffer. But it is here. Reparse data buffer. Why is this not a thing? C system extras. C. Oh, I didn't import it. That's the best kind of dumb mistakes. C system. Oh, okay. Incorrect argument call have plat from string. Oh my god. Plat from. Windows encoding unit. It's actually called something platform car. C intercorp. C interop. Anything else? I think that's the two errors we got. Oh? We got it. Okay. So that's Windows. The hard part. The next part is read symlink for POSIX. Let's see. So it's just a matter of calling read link, right? Okay. If it's Windows, else. It's a file path. We know that all right, so this part need a little bit of rewriting. So we need to do array and array of type C interop platform car. What's this? Okay, so making an array, we're gonna get the uninitialized buffer for it. All right, and then we will open ourselves up. Oh my God, how does this intent, what is happening over here? Okay. With platform string. Now we get the C string for our path. And then we will call read link. Read link is gonna be system read link. We have the base address, we have the max length. And then I guess this is how you do the error detection. This is how you do the error. And then we add a 0 towards the end and update the count. Now we have a array not terminated. Right? We have this. We can return file path platform string. Oh, interesting. This can be a pointer as well. That's fine. Okay. So that seems okay. The only thing that's left is this internal rename, internal read link. I'm guessing all you need to do here is system read link. It will take the source or the path, which is a pointer to the string type. And then it takes a second argument, let's call it size. It is a cint, and it will return a cint, right? Read link. Oh, it also takes another buffer. Wait, really? Oh, yeah. So there's a buffer, and there's a unsafe mutable pointer to the C string. Okay. Pass buffer size. Wait, this is actually an int? Really? Okay. Okay, so this is it. Let's see if there's anything nice we can do here. For example, I can do this and then do another one of this. Hold on. Here. And then another one of this here. We can also do an else. Right? And then I can cut the body. Here. So I no longer need this. Now the good thing about this is I only have one unified shared signature for the function. And it's not ambiguous as to where to document the signature. I have a feeling this might not build on Mac OS. Let's see what's been happening over here. Yeah, it built at some point. Yeah, it did build. Okay. Okay, let's do make symlink. Wait, let's think about this. Once we have read symlink and read symlink, we will be able to test it, right? We can make a symlink, we can check that it is symlink, it exists, and then we can also read the content and make sure it matches. That's good. And it's super simple on Unix, and it's not bad on Windows neither. Okay. We're closing all the issues we filed today. Still have to do copy files. This is a headache, but yeah, but I think overall it's not bad. Right, sim. Create a symbolic link to self at path. Returns wait, why does this return a path? Oh, it doesn't return a path. Okay. Okay. So on Windows, we simply do this. There's anything crazy here? Nothing crazy, as far as I can tell. With C platform, C string. Okay, the test just passes on Unix. I should say on Linux. Will it pass on Windows? It probably won't because I'm not running it in the admin thingy. So let's do that. Terminal. Run as administrator. Yeah, that one failed, huh? Unknown error. Yeah, that's fine. Wait. The question is, do I have Swift in here? I can't run Swift as an admin, right? Not really. It's more like... What's this? Do I need to normalize it? Hold on. What is the? I feel like I know this at some point and then I forgot. What is this? Windows file path. What is this? Everything is fine until this. What the heck is this? Is the pointer math problematic? That's doomed. It's doomed. If it's a pointer math problem, then we're back to the darkest moment. Oh my god. But I didn't change anything, did I? Let's print this out. What else is interesting? So let's take a look at this. We'll take a look at the final product. Let's say if it's consistent, that would mean the name length is wrong. The name length is maybe it's this. I don't know. Okay. Oh, there's a few things I can try at least. All right, let's call it. So this is 58. I have no idea what this is. Wait, it is correct. So the length seems to contain a little bit of extra data. Why is that? Is this the reason? Could this be the reason? Hold on. This will give me not a buffer anymore, right? This may not build. Yeah. Oh, yeah. This is worse. Okay. Why would there be I guess why would the Windows API give me the wrong length? Length in bytes. And apparently there's also the offset. But there must be a good reason that I didn't use it. All right, let's figure out how this thing works. So basically our struct is either this struct or this struct. And reparse data is a reparse data buffer. So which, let's see. Reparse data buffer is it's the same as the symlink reparse data buffer, right? Reparse data buffer is just this. Okay, so when we access this value, wait, what? Oh yeah, it has the reparse tag, and then it has the data length, has the reserved bit, and then it has the offset and the length, and etc. etc. And towards the end it has the path buffer. Why would it be 114? Why would it be 114? 114 divided by 2, then you get 57. But our real result is only 53. So that's 4 more than necessary. Why? Okay, so this is the whole thing. We got the tag, we got the length, we got the reserve bit is 0, the offset, substitute length. Wait, this is interesting. Print length. This is correct. This is correct. Why? Why did I not use that before? Print. So instead of using substitute name length, if I use print name length, it would be correct. So what's the relationship between these two, supposedly? Print name offset. Offset in bytes of the print name. Note that this offset must be divided by size of white car to get the, okay. Substitute name offset. Offset in bytes of the substitute name string. No, this was also divided by, what is the difference between the substitute name and the print name? Print name versus, okay. This character is followed by in memory by the remainder of the string. The path string contains the substitute name string and print name string. The substitute name and print name can appear in any order. To locate them, use the offset and the, okay. Oh, they can appear in any order? Oh, that sucks. Because I think I'm assuming they appear in a fixed order. I see. So the code, as complicated as they are, is not really correct. Because the offset is missing the starting point is missing an offset. So name offset is substitute name offset. Let me see. So we know the name, right? That the substitute name offset here is 106. The length is for some reason 114. How could that work? I should use a print name. The print name is the, seems like the one I want, right? So instead of using substitute name length, I should use print name print name length. Print name length. Yep. And then there's a print name offset. Okay. And this should add the name offset. And then you divide everything by 2. Right. I mean, it's not really 2. It should be this. This should give me a passing test. Feel like. But the question is, does it work? Because why did my original implementation worked? Yeah, it passed all the tests. Well, it hold on. Well, I'm just gonna assume it works, which is very interesting. What kind of test do we have here? We get an A, we write the thing A, we make a link B, we make a link, and then we read the link, we compare the result. It's the same test, essentially. So good thing is we have 2 Windows machines, right? The other one being the VM on GitHub. So let's see if that VM likes our tests. Okay, so if this test passes, I'm gonna call it for today's stream. I think it's very productive. We closed our biggest fear with regard to Symlink. What? Auto merge failed. But yeah, the test passed, so that's good. You can see we even revalidated our biggest fear of symlink, right? As we are trying to copy the same implementation, we found more issues. Yeah, so that's good. We kicked things forward a little bit. This one is gonna be a doozy because I rewrote the directory content to be a collection, which is something I always wanted to do for Pathos, but I never did. Directory content, as you can see, directory content is a sequence, and it has these features and different implementations on different platforms. But right now, these implementations all assume there's no such thing as symlink. Once you start to follow symlink, things become interesting, and I don't know if the current implementation can hold. So that's something. That's like a non-trivial algorithm problem. Okay. So that's probably what I'll tackle next when I feel like it. Right now, I feel kind of tired. So, okay. Thanks for watching, Gilad, and I'll see you again soon.